So, oh my goodness. So as I said, we're starting unit analysis, and I don't know, it's kind of a complicated sounding thing. It's not. It's just you're converting units back and forth. All right. Before we do any of that, I just want to review some fractions. Right. It's always, you can never review fractions enough. Uh, as much as I review fractions, there's always more people who need more fraction review. So we'll just do a few problems, and we'll kind of get into things. So, all right, and I don't know why I wrote this. Write 2 and 4/5 as a single fraction, as a single fraction. So two, I don't know, it sounds like something else. So and this kind of notation is kind of funky. Usually you don't see this like this is something you'll write like in like a cookbook or like you might see this, you know, kind of other places. But usually when in math you don't write that. There's something wrong with it, but it just kind of looks weird because writing 2 and 4/5, generally what you read it, right, is 2 and 4/5. But strictly speaking, you could read that as 2 times 4/5 because when there's no symbol, it's and you have two things next to each other, it's usually implied that they're being multiplied together. So generally, you don't see this kind of notation in math, but you do see it kind of informally. So the way what this really means is it means 2 plus 4/5, right? Like if you're baking something, it's like a flour recipe. It's like 2 and 4/5 cups flour, right? It just looks funny, but it's generally taken as 2 plus 4/5. Anyway, as a single fraction, we just need to add them together, right? So how do we add fractions? Anyone? Uh, so recall you have to get a common denominator, right? So remember the terminology. So the top of a fraction is called the numerator. The bottom of a fraction is called the denominator. So when they say you need a common denominator, they're saying that the bottom of this fraction is not the same as the bottom of this fraction. And so the way you can kind of interpret it is you can write it as 2/1 plus 4/5, right? So you can always interpret any number like 2 or 7 or 18. You can interpret any of those as a fraction by just putting it over 1. And then so the denominator here is 1. The denominator in the second fraction is 5. And so to add them, I have to get a common denominator. And so what all that means is that I can just multiply 1 and 5 together. And that will give me my common denominator, right? So once you have your common denominator, or your what you want to be your common denominator, you just multiply each fraction by it over itself. So it's easier when I show you it. So basically, I'm going to do 2/1 times 5/5 plus 4/5 times 1/1. All right. And so now they both have the same denominator. It's 1 and 5 and 5 and 1, which is the same thing, right? So I'm going to kind of go in my space here. So this becomes 2 times 5 over 1 times 5. So that's 10/5 plus 4/5. And now they have a common denominator, so now we can just add them straight. So I can add 4 plus, or 10 plus 4 is 14. And then the bottom, you don't do anything. Right? So again, it's called you get a common denominator. Right? So I'm assuming you've seen fractions before, right? Most people have seen fractions before at some point in their lives, but so it shouldn't be new, but it's a little review. Right? Let's try another one here. So this is already, I'm already giving you this as just the addition of two fractions, right? Um, and actually, maybe let's jump to the third one, and then we'll go back to the second one. So the third one, this is multiplication, and I did it up here, and I didn't really mention how I did the multiplication, so I just want to make it a little more clear. So to multiply two fractions, multiplying two fractions is much easier than adding two fractions, because all you do to multiply is you multiply the tops together, and you multiply the bottoms together, and that gives you your new fraction. So for instance, in this 9/10 and times 5/4, I don't need to do anything as far as denominators go. I just multiply the tops. So 9/10 times 5/4. So you multiply the top, so 9 times 5 over 10 times 4. And so what is that? That's 45 over 40. All right. So there you go. Right, so that's fine. And so that's what I did up here too. So you'll see 2 times 5 is 10, 1 times 5 is 5, 4 times 1 is 4, 5 times 1 is 4. So I did that same procedure when I got my common denominator. All right, anyway, so now let's go back to adding. So now I have 1/2 and 3/4. So 1/2 plus 3/4. And again, so the denominator in this first one is 2, because that's what the bottom is. And the denominator on the second one is 4. Oh, no worry, Gage. Um, so we have to get a common denominator. And the way we're going to do that is, just like up here, I'm just going to multiply the two different denominators together, and that would be my common denominator. And that will always work. It might not be the most efficient way, but it will always work. So,
I have a question.
Yeah.
So since these are simple fractions, can we just change that to 2/4? Like 1/2 just to 2/4 because it's the same.
Yeah.
It's
Yeah.
not simplified.
Exactly. That's what you're doing when you get a common denominator, essentially. So like the way I see what you're saying. Yeah, totally. That's a little simpler. Yeah. So what she's saying is I can just do this. Instead of multiplying by 2 and 4 to get 8 and use that as my common denominator, I can write it as 2, well, I'll do 1 times 2 over 2 plus 3 over 4. And I won't change this second one at all. And so I'll get 2/4 plus 3/4. And then now the denominators are the same. So now we just do what, 5/4? So that works too. So if you can just change the 1 to make it into the other denominator. If they're not multiples of each other, you can't really do that. So it's a little more difficult. But yeah, that works too. That's a faster way. Right. And it's going to be the same answer you would get if you did it the less efficient way too. So I'll do that onto this other sheet of paper here just so you can see it. So 1/2 plus 3/4, right? So the kind of less efficient way would be just to multiply the denominators. So I'll multiply this whole fraction by 4/4 and multiply this whole fraction by 2/2. And then the denominators will necessarily be the same. So I'll get 1/2 times 4/4 plus 3/4 times 2/2. All right, now the denominators will both be 8. When I multiply these out, I'll get 4/8 plus 6/8. And now I can just add the numerators. So I get 10/8. Right? And it might not look the same as the answer we got here, 5/4, but remember, with fractions, you can cancel like terms. So I can factor out a 2 from both. So 2 times 5, 2 times 4, and I can cancel the 2's to get 5/4, which is what we had before. Right? So either way you like to do your fractions, just what we'll use here is mainly the addition. We'll use multiplication. I don't think we'll do much division, but it's okay. Division you should know how to do, but I don't think we do any of it here. Maybe we'll do one division problem just so I can see I did it. So let's try another one. So 4. Let's divide, I don't know, 1/3 by 7/8. So to divide fractions, if you might have heard keep, change, flip, right? So you keep the top the same, you change the division to multiplication, and you flip the bottom fraction. So again, keep the top, change division to multiplication, and then flip the bottom fraction. So what that means is you put the denominator in the numerator and the numerator in the denominator. So it's 8/7. And then multiplication is just across. So it's just 8/21. Right. So you can also divide fractions, of course. So we'll use a little bit of this. Let's move on though. So let's see. So now into proper unit analysis. So blank is a number that describes the size or amount of something, a measurement. I forgot the A, apparently. A measurement is a number that describes the size or amount of something. The process of converting, as I said earlier at the beginning of class, converting between units and measurements is called unit analysis. And so basically, for this entire chapter, and part of this unit, we're going to be studying how to convert between different kinds of units. And just to start off, we'll kind of break them down into certain types of measurements. So we'll do length, width, and then capacity, which is kind of like volume. Like think like liquids, like if you're doing baking, again, like oil, like how much oil do you need. But the first, as I said, is length. So length is the distance from one end of an object to another. So that's length. Think of like a ruler. And I say here, the inch is the smallest unit of length. That's really that we'll use. For now. And that will be true for all the other sections. So width, the smallest, or no, not width, weight, the smallest we do is an ounce, I think. Then the other one is a fluid ounce. So we have these smallest units, but they're not actually the smallest units. Of course, you can define smaller units, but like a millimeter is less than an inch. But we're not talking about that right now. Right now, we're just talking about U.S. measurements. I think they're usually called imperial measurements. So inch, feet, yard, mile. So an inch is the smallest we'll talk about right now, and everything else can be defined in terms of the inch, essentially. So a foot, how many inches in a foot?
12.
Yeah, 12 inches in a foot. And then yard, we have 3 feet in a yard. All right. And then a mile, you could say it's 1,760 yards. I don't usually use that. Usually I think of it as 5,280 feet. Right. And then you could also get these in inches too, right? Like 1 yard is 3 feet, but if each foot is 12 inches, then of course it's 36 inches. Right? So and then this one, if you multiply this number by 12, that would give you the amount of inches in a mile. So you can get them all in this base like inch thing. But now more importantly is this. So a conversion factor is it's basically you take a fraction and you put the units in them that are the same. So for instance, 1 foot is 12 inches. So if we put 1 foot over 12 inches or 12 inches over 1 foot in a fraction, we would call that a conversion factor because it's essentially equal to 1, but it's relating 2 different units to each other. And then using conversion factors to convert units measurement is called, oh God, what is it called? The book gives us a weird name. And I'm going to be entirely honest, I forgot what it calls it. I've never heard it before. Wait, let me just check. God. The factor label method. I'm almost certainly not going to use this phrase. The factor, but I'll put it in here in case you do read the book. The factor label method. It's just a weird phrase. I don't know if I've heard it called before. If you've heard it called that before, let me know. Basically, the idea, though, as I said, is we're going to take these conversion factors, and we're going to take one unit that we want to convert into another unit, and we're just going to multiply our unit or our measurement by these conversion factors until it's converted into the appropriate unit. So let us try an example. Well, I guess 3 examples. So, and a lot of these you can do just straightforwardly. Like you don't necessarily need this this unit conversion method that we're going to do for these, or really any of them technically. But it's really just a system that helps set up kind of like it's a more rigorous way of converting units. That's more useful when you have more difficult units to convert. None of them are really that difficult, but I guess more complicated is the word. So. Again, obviously, I think most of you could probably convert in find how many inches are in this many feet without this method. But again, we're trying to set up like a system to help us, rigorously do this. Anyway, so how many inches are in 8 1/3 feet? And again, this is like a callback to that first fraction stuff we did. Again, I'm not taking this to be 8 times that. I'm taking it in the informal way where it's 8 1/3 foot. So the first step I want to do is just get this as a single fraction. Right, so maybe so I don't know. I'll do it up here. So 8 1/3 equals 8 plus 1/3, and again, it's very informal, this way of writing it. You usually don't see that, except in like cookbooks. But anyway, we get a common denominator. So you can think of it as 8 over 1 plus 1/3. So I'll just multiply this fraction by 3 over 3. So I get 8 over 1 times 3 over 3 plus 1 over 3. And now they have a common denominator of 3. So it's just 24 over 3 plus 1 over 3. And so I get 25 over 3. Right. All right.
Hey, Matt.
Yeah.
Can I just, the way I learned it to figure it out is that I took the 8 1/3 and then I multiplied the 8 times 3 and then added the 1, just kind of work around
Yeah.
like in a half circle.
Yeah, that works.
Okay.
Yep, same thing, I think. It's just, yeah, however you learn these things, if you learn them differently, then totally use whatever method you're comfortable with. I'm just kind of, I don't care what method you use, as long as it's correct. Right. Anyway, so we've converted this kind of informal presentation of a number into this actual fraction. So 8 1/3 feet is more strictly speaking 25 third feet. It's a weird way of saying it. But now we can convert it into inches. So I have 25 third and over 3 feet. Right, and so what we're going to do is I'm going to multiply it by a conversion factor such that the feet cancel and I get inches. And so the way these factors work is that we're treating the units like they're numbers in a fraction. And so we'll cancel units like we would cancel that 2 I canceled earlier in that fraction, or we'll cancel feet like I canceled that 2 earlier in that fraction. So, so for instance, what I'm going to multiply this by, I want the feet to cancel. So I know there's 1 foot equals 12 inches. So I'll put the foot in the bottom. And now, as I said, the feet cancel. And I know there's 12 inches in a foot, so I'll get 12 on the top. All right. And now, as I said, feet go away. And you can't, you kind of compute this just like we would multiply any other fraction. So 25 times 12 over 3 times 1. And the only units left will be inches. All right. And so you can plug this in your calculator, or you can realize that 12 over 3 is 4. And so I just get 100 inches.
Could you just times 8 by 12 and then figure out how much 1/3 feet are and add them together?
Mm-hmm. That too. That would also work. So what she is suggesting is, so I'll put like a, so what she's suggesting is you have 8 basically plus 1/3. And so this is in feet. And I do want, even if you do a different method, I do want to see your units. And so what you're doing is you're really just saying this is equal to 8 plus 1/3 times 12 inches. And so it's 8 times 12. What is that, 96?
Yep.
And then plus 12 over 3, which is 4. Which is the same as that. Okay. So either way is okay. But do be careful with your units. And this sort of, I would like to see conversion factors in general. Because as I said, we'll do some units, I think at the end of this chapter, that are like ratios, and they get slightly more complicated. So it does help when they are kind of set up nicely. All right, so next one. How many feet in this 5.89 miles? So we get a calculator. So this one is just a decimal. I can't do anything with it to like make it pretty or anything. I mean, it's as pretty as it's gonna get. It is just 5.89 miles. And I want to know how many feet. So I'll just do the same thing. So I start with what I have, 5.89 miles. And again, I want to get rid of the miles and replace it with feet. So when I multiply it by my conversion factor, I'm going to put 1 mile on the bottom because I want miles to cancel. And then I want it to be in feet, so I want feet up here. And so you just have to ask yourself how many feet in a mile. And I told you it was 5,280. And so you would now multiply them across, just noting again that the miles won't necessarily cancel. And so with my handy dandy calculator, I get 5.89 times 5280. And so it's about, well, I guess I can just say exactly. It's 31,099.2 feet. So it's a lot of feet, but it's almost 6 miles. So it makes sense. Right. Questions so far? Again, so just kind of note how you're setting up these conversion factors. And then lastly, how many inches in 4 miles? So I'm starting with miles, so 4 miles. Right? And I want it in inches. So this one, I'm going to do using 2 conversion factors. So again, for any of these units, there's always different ways to do it. You could just initially find out how many inches there are in a mile and use that as your conversion factor, essentially. But I'm going to go from miles to feet and then inches. So I'm first going to use a conversion factor to convert from miles to feet. So I want 1 mile, so I want to go to miles and make it into feet, 5,280 feet. Right? But I want it in inches. So now you'd say, oh, how many inches in a foot? Right? And so 1 foot equals 12 inches. And now look at the units, right? So this is kind of where it gets somewhat interesting. So again, the miles will cancel there, and then the feet will cancel there. And the only units that are left in this product are inches. And so my answer will necessarily be in inches. So it's 4 times 5,280 times 12. And again, you use your calculator, in inches, of course. And so it's some ugly number. Oops. 4 times 5280 times 12. Oof. It is just about 250,000 inches. 253,440 inches. So that's a lot of inches in 4 miles. You could hike 4 miles. I guess it's not hard to walk a few inches. So, any questions about this? So again, we're using 2 conversion factors, and there's no set way to set up these conversion factors. It just depends on what you want. So, for instance, if I go off to the side here, so if I go back to this problem, maybe if I go back to this mile one here. So if I was doing this problem, so it's 5.89 miles, and I want it in feet, right? And so this is the conversion factor I use to get it into feet. But what if I had done it the opposite way, right? What if I tried to multiply it by 1 mile or 5,280 feet, right? Like what happens here? And you'll know that it's kind of weird, right? If you look at the units, I have miles squared over feet. Like what I don't, that's not a unit. I mean, it is a unit, but it's not a unit you've heard of. So your answer here would be 5.89 times 5.89 over 5,280. And then as I said, miles squared per foot. So like a lot of question marks. Like it's not the units you want. You wanted it to be just feet. So if you're doing this kind of problem and you get units that are really funky, you should say, oh, maybe my conversion factor is not the right order or something like that. So with these, it kind of makes your life easy because there's only one, I mean, there's multiple ways to do them, but in the end, if you did it wrong, you'll see because your units won't work out right. So the units here are really crazy. And so I should say, oh, I did it wrong. Let me go back and double check. All right. So moving on. So that's length. As I said, we're going to do a few of these. So we have length, we have weight, and then capacity. Again, capacity is kind of a weird phrase for it. I think it's usually volume, but so let's go with the weight though, and then I'll keep going. So weight. Weight describes how heavy or light an object is, obviously. And then, as I said here, an ounce is the smallest unit of weight. Again, that we'll use. There are obviously smaller units of weight in existence, but we're just not using them right now, right? And so an ounce or a pound is 16 ounces. Oh, that's so much better. Okay, I'm sorry. I hope that wasn't blurry the whole time. Sometimes it's blurry and it seems like it's on my end, but then I don't know. If it's ever blurry, yell at me. The autofocus on this sometimes goes off. I think I fixed it though. I apologize. So a pound is 16 ounces. 1 ton is 2,000 pounds. Okay. Cool. So how many ounces are in 3.5 pounds? Again, using this kind of informal system. So ounces and how many ounces are in 3.5 pounds? So we know that 1 pound is 16 ounces. So it's just a matter of multiplying by the right conversion factor, right? So I'll do 3 plus 1/2 pounds. And we'll write this 3 1/2 pounds equals 3 plus 1/2 pounds, right? And then my conversion factor, I can just, I mean, you could be in the past, like in the past few problems, I've combined these to be the same, to get one single fraction. But if you don't like doing that, you don't have to. It just makes my answer a little neater. If I didn't want to do that, I could just kind of just jump straight to the conversion factor. And as I said, I want it in ounces. So I want to get rid of the pounds. So I'm going to put my pounds in the bottom, my ounces in the numerator or the top. And then 1 pound is 16 ounces. So I'll put 16 there. And we're all set up now because pounds cancel and I just get ounces. And so now this is the same as, again, you can think of this as two fractions, right? In this fraction, I have a 1 in the bottom. So I don't multiply anything in the bottom. But on the top, it's going to be 3 plus 1/2 times 16. And then the only thing left is ounces. Right. So it's just 3 times 16, and then 1/2 times 16. Right. So what is that? Is that 48 plus 8? 3 times 16 plus 8. Yeah, 56. So 56 ounces. So again, it doesn't matter that it's length or weight, or it doesn't matter what your actual measurements or units are. The method by which we're doing these conversions is identical. It's just that they're going to change a little. Right. Oh, and for the test, I mean, it's like we literally just finished a test, but on the test for this chapter, you won't be asked to memorize these units. I'll give you like a big formula sheet, or you'll get a big formula sheet probably, having all the ones you'll need on it. No one knows how many pounds are in it. It's silly. Everyone, you just ask Alexa how many like cups are in a fluid ounce when you are baking, right? So that's all good. And then this next one, what is 8 ounces in pounds? So I start with my 8 ounces, so I write that down. I want it in pounds, so I'm going to multiply it by a conversion factor that has pounds in the top, ounces in the denominator, and then I just try to find a relationship between them. Strictly speaking, it doesn't matter what the relationship is, right? So like in my case, I have 1 pound equals 16 ounces, so 1 pound equals 16 ounces. So that's what I'll put. But for instance, if for some reason you only knew that 2 pounds equals 36 ounces, that would also be fine, right? Because the 2's would cancel and you'd be fine. So it's a ratio. It doesn't have to necessarily be the definition. It can be any ratio of the definition as well. Not that you'd ever really use that. But in any case, you'll note the ounces cancel, and I just get 8 times 1 over 16 pounds. And that's 1/2 pounds. So you 8 ounces, half pound. Something you might have known just because 1 pound equals 16 ounces, but makes it exact. Questions so far? All right. I think a lot of people already know these the conversion factor business, especially the nurses, I think a couple of last semester when I taught this, a couple of the nurses said they had already taken this and were quite good at it for obvious reasons. So if that's you, then you get a break. But, all right, let's do an example with words. A municipal trash facility allows a person to throw away a maximum of 30 pounds of trash per week. Last week, 140 people threw away the maximum allowable trash. How many tons of trash did this equal? Right, so we have 140 people throwing away 30 pounds of trash. And we want to know how many tons that is. So the first step, right, is to find out how many pounds that is. because we are given the trash weight initially in pounds. So we have 30 pounds of trash per person. And there's actually a cool way to do this. I think I'll just do it like this though. I think it's a little simpler. So we have 30 pounds of trash per person, and we have 130 people. 140 people, sorry. And so, right, you just multiply those together, and that will give you the total amount of trash. So in pounds. So let's see, 30 times 140. So it's 4,200 pounds of trash. Okay. And now we just need to convert that poundage number into tons. And before I do that though, I want to note, the other way you could interpret this statement, and it's something that I think we'll talk about later, but it's this word per. When you see the word per, P-E-R, P-E-R, I can't spell, it's 3 letters. When you see the word per, it basically means you're dealing with a fraction, right? So when you're talking about like a velocity or like a speed of a car, you're talking about miles per hour. So every hour you go that many miles. Here we're talking about pounds of trash per person, right? So the way you could interpret this is 30 pounds of trash per, so it's a fraction, 1 person, right? And then what I'm doing here is I'm multiplying it by 140 people. So times 140 people, 140, and I'll just say persons to make it the same. And you can kind of think of it like unit analysis, like the way we've been dealing with units where we cancel units and stuff like that. You can think of this as the same way. You can think of it as, oh, the persons cancel, and all I'm left with is pounds of trash. So this is 4,200 pounds of trash. All right. So whenever you see the word per, it really is just a fraction. And this is something that you probably could have just figured out implicitly, but it's really neat that we can view this under this kind of lens of unit analysis. It's really interesting. It's like everywhere. I think it's sort of something to do with symbolic like logic, but that's besides the point. So now how many tons is this? And so now we just converted it to tons. So I have 4,200 pounds. At this point, it doesn't matter, that's trash. And I'm going to multiply it times. So I know there's 2,000 pounds in a ton, and I want to get rid of the pounds, right? So I'm going to put pounds down here, ton up there, and as I said, 2,000 pounds in 1 ton. And now the way we've set this conversion factor up, the pounds cancel, and I get my answer. So it's 4,200 over 2,000 tons. And so what is that? 4,200 divided by 2,000, it's 2.1. Yeah. I don't know if that's how you spell tons. There's an English version, it's like T-O-N-N-E-S. I don't know if that's how we spell it here. I don't know. It doesn't matter. Plural. If you're English, then put an N and an E in there. But if you're not, I think that's acceptable. Don't quote me. Any issues with this problem? It's a 2-parter, right? The first part, we just found out how many pounds. Interesting to use the unit analysis for that. And the second part, we just converted it with a conversion factor like we've been doing. Okay.
I Googled it. That's the correct way to have
Is it?
tons in math.
Oh, perfect. Okay, thank you. All right. Let's just do one more, and then we'll go to capacity. Again, I don't know why capacity is the word, but it's all good. So the average weight of a northern bluefin tuna is 1,800 pounds. That would make so much good sushi. The average weight of a great shark is 2.5 tons. How much more does a great shark weigh in pounds than a northern bluefin tuna? So we already have the weight of the tuna in pounds, we want to know how much the tuna or how much the shark weighs more in pounds. So the only thing we have to do really is convert the shark's weight into pounds. So, and then we can compare them and find the difference. So I have 2, and I'll just write it as 2 1/2. I think that's a little simpler. Tons. And then as we've been doing, I want it in pounds. So I'll put the thing I want to get rid of in the denominator. So I'll put tons in the denominator because I want that to cancel and go away. And I'll put pounds in the numerator or the top because I want that to stay. And it's 2,000 pounds in 1 ton. And now, of course, the tons cancel by design. And we get in our answer in pounds. So what do we have? We have 2 plus 1/2 times 2,000 pounds. And you could just plug that in a calculator, or like we did before, you can distribute. So remember, when you're multiplying something in parentheses by something else, you have to distribute the thing on the outside in. So here, it's going to be 2 times 2,000 plus 1/2 times 2,000. And again, it's all in pounds still. So what is that, 5,000 pounds? Right. And so the bluefish, the bluefin weighs 1,800 pounds. The shark, the great white, it doesn't matter, weighs 5,000 pounds. So the difference is what? 3,200 pounds. So the difference is 5,000 minus 1,800, which is 3,200 pounds. Right. So it's a big it's a big shark. I hope they don't actually weigh that much on average, but I think that's terrifying. All right. He would eat you without, you'd be like I don't know, like a toothpick, a scrap dinner, terrible dinner. But it's huge. It's a big shark. All right. Anyway, capacity. Again, so capacity is just kind of like volume, liquids. Think of like gasoline or oil, like cooking oil, I guess also crude oil. But capacity is the amount of liquid that an object can hold. The smallest unit measurement for capacity, again, that we will use right now is a fluid ounce. And I wrote them down already because I constantly have to ask Alexa what these are when I'm cooking. So, so there we go. So 1 cup is 8 fluid ounces. I will never know that. 1 pint, maybe I will now. 1 pint is 2 cups. 1 quart is 4 pints. 1 gallon is 4 quarts. And of course, you can kind of backtrack these a little bit. So for instance, if 1 pint is 2 cups and 1 cup is 8 fluid ounces, how many fluid ounces is a pint? So it's going to be twice of the 8, so it's going to be 16. Oops. Fluid ounces, right? And then you can keep going, right? So you could get the quart in terms of cups by multiplying, if a quart is 2 pints and a pint is 2 cups, then 1 quart is 4 cups. And then you could get that in fluid ounces. Again, it's going to be what? 4 times 32, so it's 36. Well, no, 4 times 8 is 32. I got ahead of myself. So you can keep going back, but I won't bother because I'll just use these main ones that I wrote in pencil. But just know that you can get everything kind of related together if you so desire. But let's try some examples with these uglier liquidy units. How many pints in 2 gallons? How many cups? So my starting is 2 gallons. All right, start with that. And the first part wants how many pints. So go to my little chart here. So 1 gallon is 4 quarts. And then 1 quart is 2 pints. So the first step is I'm going to get the gallon into quarts. So again, gallon I want to get rid of. 1 gallon is 4 quarts. And so now I'm in quarts because the gallons cancel. Well, that's not what I want, right? I wanted pints. So since I'm in quarts, I go to my chart again and I say, oh, 1 quart's 2 pints. So I can now convert to pints. So 1 quart again, quarts in the denominator here because I want them to cancel, is equal to 2 pints. And now we're done for the first part, right? So if I multiply these 3 terms through, I get 2 times 4 times 2. So what is that? 16 pints is 2 gallons. So that's the first part, how many pints. And the second part asks how many cups. And so to do that, you just go and look at your chart again. So 16 pints. And you say, oh, 1 pint's 2 cups. So I'll multiply it by the appropriate conversion factor, putting pints again in the denominator because I want that to go away. And what is it, cups? So 1 pint is 2 cups. And there you go. Again, pints cancel. And we're all really nice and neat. So we're just 32 cups. Right. So these conversion factors are really great. And as I did in that other problem with that garbage, you can really use them for kind of an array of things. They don't have to be just for units. They can be like pounds of trash per something. It doesn't have to be even per person. It could be pounds of trash per like square mile or something like that. So you can do a lot of neat conversions, even though they're not really units. You might think of as units. Right? All right. How many gallons? All right. Any questions this one? Sorry. Before we move on. All right, how many gallons is 16 fluid ounces? So gallons, 16 gallons. All right, and now I want in fluid ounces, and we're really going all the way back now. So if you go back to this previous page, I have 1 gallon equals 4 quarts, 1 quart's 2 pints, 1 pint's 2 cups, and finally 1 cup is 8 fluid ounces. So I want it in the smallest unit of measurement. So what that means is I have to do 1, 2, 3 conversion factors, and then I'll be good. So I'll work my way back, kind
Question.
of like I did here. Yeah?
Am I reading this wrong, or is
You-
it 16 fluid ounces, 2 gallons?
You aren't. Thank you for my lack of reading. How many gallons is 16 fluid ounces? Thank you. So we're doing the opposite, is what I was saying. We're starting here in the fluid ounces, and I want to figure out how many gallons that is. So I'm going to multiply by the appropriate conversion factors to get to the bottom now. It's the opposite of what I was saying. So I guess I'll put one here. I don't, it won't fit, but it's all good. So so 1 cup is 8 fluid ounces. So I'll convert to that. So 1 fluid ounce, things like that, is oh wait, sorry, 8. 8 fluid ounces is 1 cup. Let me just rewrite this on this other sheet of paper. It's really messy. So 16 fluid ounces. There we go. We'll start like that. So I have 8 fluid ounces in 1 cup. All right. So that's this first relationship. Now I'll work my way down. So pints, I have 2 cups and 1 pint. So 2 cups in 1 pint. And now again, you'll note, so the fluid ounces have canceled. So I'm in cups here. And then the cups cancel. So I'm in pints. And then 2 pints in 1 quart. So I want the pints to cancel. So pints, 2 pints in 1 quart. And then lastly, and so now the pints cancel. And lastly, I want it in gallons. So there's 4 quarts in 1 gallon. So I'll put it down here. So what is it? 4 quarts in 1 gallon. So I want the quarts in the denominator, so they cancel. 4 quarts in 1 gallon. Right, and now the quarts cancel. And we're good. The only thing left is gallons, and we should multiply it all through. So on the top, I got 16 times 1 times 1 times 1 times 1. So that's 16 in the top. And at the bottom, I have, well, there's like an implicit 1 down here, but 8 times 2 times 2 times 4. Right. So that's 16 times 8. So that's just 1/8 gallon. Right. So it's 1/8 of a gallon. But yeah, so this is really where you'll kind of use these conversion factors more, is in these longer stretches of units where you want one thing in another unit and they're kind of apart from each other. Now, of course, you could have done it in steps. You could have just done each step on its own, but this way makes it really nice and concise, and it gives you this really kind of cool chain where everything cancels except exactly what you want. So. All right, questions with that one? All right, so, man, we're almost done. Shoot. Yeah. These didn't take as long as I anticipated. All right, so let's do this last example, I guess. Maybe we'll end early today. All right, so Alan is making chili. He's using a recipe that makes, again, 24 cups. So when you're reading these problems too, just in general, when you're doing like problems with words and stuff like that, word problems, make sure you just identify the important things. So 24 cups of chili, that should be important, probably. He has a 5-quart pot and a 2-gallon pot, and is trying to determine whether the chili will fit in one of these pots. Which of the pot will fit the chili? Right. So we have some options here, right? We want to figure out, basically, we want to compare the capacities of these different items, right? We have 24 cups of the chili, and he needs to see if it will fit in the 5-quart pot or the 2-gallon pot, or both. And so the one thing you could do is you could convert the 24 cups to quarts and gallons, which is a valid way to do it, or you can convert the gallons into cups and the quarts into cups. So I don't know. I think I'll do it that way. I'll convert both of the pots, the quarts and the gallons, into cups, and then be able to compare them. But just note you can do it the other way too. So, so the 5-quart pot. So again, we go back to our handy dandy chart. The 5 quarts. Let's see. So I want it in cups. So if I'm here, 1 quart is 2 pints, and then 1 pint's 2 cups. So it's only 2 conversion factors, right? First, to convert the quarts into pints and the pints into cups. So 1 quart is equal to 2 pints. So then those quarts cancel. And then 1 pint is 2 cups. So I'll put the pints in the denominator. It's 2 cups. And now the pints cancel. And we're just in cups. So altogether, this 5-quart pot will hold 5 times 2 times 2. And then the bottom, I just have 1 times 1 cups. And so what is that, 20 cups? Because it's 5 times 4, which is 20. Right, so this 1 pot will hold that many cups. So namely 24 cups of chili won't fit in this first pot, so it won't fit.
If we wanted to, could we just stop right there and just write the 2-gallon one?
It might not fit in that one either. I guess you could, I guess it's kind of implied that it will fit in one. But yeah, you could theoretically stop there, but we won't. All right, so 2 gallons. I want to convert this into cups. So let's see. So 1 gallon is 4 quarts. Again, the gallons go in the denominator, 4 quarts. I keep wanting to put a Z at the end of that, like it's a mineral and it's not a mineral. I don't know what's wrong with me. All right, and then every time I write it, my mind thinks of the Z, and it's like I have to think of myself, it's not the Z. All right, and then 1 quart is 2 pints. So 1 quart is 2 pints. All righty, and we're getting there. And then 1 pint is 2 cups. 2 cups. And now we're in cups, because all these gallons, quarts, pints, all cancel. And like I've been saying, like the units canceling are really helpful for you because they almost kind of show you that you've done it right. If everything cancels appropriately, you can say, oh, I'm done. It's good. It's successful. If they don't, then it isn't. So it's really easy to see when you've made a mistake with these. Oh my goodness. All right, and now we just multiply across. Again, treating them like fractions. So I get 2 times 4 times 2 times 2. 2 times 4 times 2 times 2. And then in the bottom, I get 1, 1, 1, which don't really contribute, obviously. And so what do I get? I get 4, 16, 32. 32 cups. So this is the winner. Chili will fit. Yeah. And that's it. If I was smarter, I would have put like a GIF of Kevin dropping his chili or something. But I'm not that smart. So, any questions? I think we'll end early today. These didn't take very long. Any issues? Are you people vaguely familiar with unit analysis? Yes,
Yeah.
no, maybe. Yeah. All right. Yeah. So I'll put some more homework on this in the near future, but oh, sorry, I'm just taking a picture of the attendance. Yeah, if you don't have any questions, we can we'll call it a day. All right. So I'll see
One
you.
question,
Yeah.
but it's not based off of the math. It's
All good.
October 13th is Columbus Day. Do we have class? Because
The
my
third.
other two classes don't.
Is it a JCC thing?
I'm not sure.
Let me see, just a second. What, it was October 13th, you said?
Yes.
Let's see.
Well, technically, it's the 12th.
Oh, yeah. It's all good. Let's see, is it 2021? Yeah, it is. Not really, but you understand. October 13th, no classes. Yeah. October 13th, no classes, faculty development day. So yeah, another thing. And then Monday is fall break. The 12th is also off. So Monday and Tuesday, both no classes. So what is that? That's in 2 weeks. So it's exciting. Any other questions? All right, cool.
Is there
So,
homework due this week?
no, there won't be anything due this week. I'm trying to do it like one thing a week. So like the test was this week, so I'm counting that as like the thing. There will be homework due next, like a week from tomorrow, though.
I thought the open math said it was.
There was. Wait, there's a geometry due tomorrow. I'm a liar. Yeah. Wait, just a second. Let me look at this. There isn't. I forgot about the geometry one. I thought I put it earlier, but it's not. I gave you extra time. Yeah, there's a geometry homework due tomorrow, technically. If you need more time, let me know. Because sometimes the late pass system isn't working as well as for some. It seems to be broken. But let me see how people are doing with it. About half of you have it finished already. So if the other chunk of you need some more time, let me know. Or if you have questions on the homework, I can help you with that too. I'm free tomorrow. But yeah, so that's due tomorrow. Thank you for reminding me. Yeah. And then next week on Friday, there'll be another assignment. Anything else? Cool. So again, give the homework a go. Try to finish it today. If not, if you need more extra time, let me know. But try to finish it today at some point. But I'll see you Tuesday.